So it may have been a while since you've seen systems of equations, but it is going to come up in this chapter. So let's go over how to do this. If you've already got it done, then just pay attention. There are a couple different ways to do this problem. This one is, to me, this looks set up for elimination because the x's and the y's and the equals and the constants are all lined up over top of each other. So that's how I'm going to do it. Although it would be pretty easy to do this with substitution also. If you're going to do substitution, you probably would get this x by itself and then substitute that into the other equation. Did anybody do substitution for this one? We'll be reviewing substitution on Wednesday as well. Stacking them is elimination. Substitution's where you put something into the other one. Okay, cool. And we should get the same answer no matter what method we use. So I'm going to go for elimination with this because they're all stacked on top of each other. But what I want is, and I'm not seeing this right now, what I want is either for my x's to cancel out. Like if that had been like a negative 1x and a positive 1x, or negative 3x and a positive 3x, they'd cancel. And that's not happening. It's not happening with my y's either. We can make that happen, though, by multiplying one equation or both equations by any number we want. So I'm looking at the bottom one and thinking, if I want my x's to cancel, I want to turn this 1x into a negative 3x. What am I going to need to multiply the bottom equation by so that becomes a negative 3x? I'll just multiply it by negative 3. But then I need to multiply the entire equation by negative 3. So negative 3 times 1x is negative 3x. Negative 3 times 2y is going to give me negative 6y equals negative 3 times 4 is negative 12. So I've modified the bottom equation by multiplying everything by negative 3. That's a legal move as long as we're multiplying every term on both sides by the same number. And the top equation I'm not going to modify at all. I'm just going to copy it over here. And then when we go to add these equations together now, which would be our next step, the x's should eliminate. When you add a 3x and a negative 3x, those are going to cancel each other out. And you're going to have an equation that just has y's in it. So this one's going to end up being, what is that? 9 plus negative 6 would be 3y equals, and 33 plus negative 12 would be 21. Hi.
I need the missing work.
Not right now. Come back after class, please. Or at the end of the school day. Thank you. Okay, and then 3 is multiplying by the y, so we'll divide by 3 on both sides. And that'll get us y equals 7. We're not done. That's only half of our answer, but we've done most of the work. Any questions up to there? Is this looking kind of familiar? Do you guys remember how we figure out the other half of this solution? We also need an x value. Yeah, we're going to stick this 7 back into which equation? The top one or the bottom one, or it doesn't matter, our choice. You can do either one. Which one would you choose? Bottom one has smaller numbers. I like smaller numbers. I'm going with the bottom. So I'm going to take my bottom equation and rewrite it. It was 1x plus 2y equals 4, but I left my y out. And I left it out because I now have a value for y. My value for y is 7. So now that equation is x plus 14 equals 4, and we know how to solve that. We'll do minus 14 on both sides and get x equals negative 10. Yeah, sometimes. I don't know. I just try and do things in different colors for different steps. Is it confusing for you guys?
No, I just.
Okay. It helps me to see, like, yeah, it helps me to see, like, where did this 7 come from? I can kind of see if it was the same color over here. That's a good idea. I'll try that. Like, do my x's in one color and my y's in another. Yeah. we still need to check this. It does tell us to check. So if you didn't check your solutions, I'd like you to do that with me right now. What I'm going to do is I'm just going to down here, I'm going to rewrite both of my equations, but I'll leave my x's and my y's out. So 3x plus 9y equals 33. And then my other equation was 1x plus 2y equals 4. I'm going to try your suggestion here. So my x was red. So I'm going to fill in where all the x's were with negative 10. And I'll put my y's in blue. We'll make them 7s. And we'll see if this works out. If it works out, if we should be able to simplify this side, and it should end up being the same as this over here. So let's see if it works. This would be negative 30 plus 9 times 7 is, help me out here, 63. And negative 30 plus 63 is 33. So 33 equals 33. That checks out. We just need to check the other equation and make sure it works as well. Negative 10 plus 2 times 7 is 14. Negative 10 plus 14 is 4. 4 equals 4. That works. That checks out. Do you guys remember how to write your final answer? We put it in parentheses with a comma in between. X first, y second. So negative 10, comma 7 for our final answer. And we did check that, so feeling fairly confident. Let's go ahead and circle it. Did you bring me a note? What's that? Okay. Check in with me after class to make sure, because I've got you marked absent, and I don't want to leave it that way. Just remind me, because I'll forget. Okay, there were other ways to do this problem. Some of you may have started from the beginning. You might have taken this first equation and done minus 2y on both sides to get x equals 4 minus 2y. Did anybody do that way? And then take that 4 minus 2y and stick it into this equation in that spot. So this equation would end 3x plus 9y equals 33, but you could have put that 4 minus 2y in that spot and then solve that instead. You got the same answer that we did. So that you use substitution instead. We'll be practicing both on Wednesday. Okay. Thanks for your attention there. You can tuck that away. We won't be